We're ready for math today, math being Friday, March 27th. So make sure you're on the right video. Okay, today for math, you're going to need page 243 to page 244. You're also going to need your speed drill. Got your speed drills back. Speed drill lesson 122. So if you have your speed drill, nice little things you can color there. Lesson 122. Make sure your name's on it. And looks like we are doing our fractional part of a number. So, got some nines on there. Make sure you have those tables handy. It's like they're all 5s and 9 tables, okay? So I'm going to go ahead and give you 2 minutes, it says, for that. So you can go ahead and ready, begin. You have about a minute left. There's my timer. Okay, so time is up. If you will lay that to the side for today. Turn this off. Put that down. Okay, so for today, we're just going to go right into our lesson today. We're going to go ahead and grab our paper. We're going to go ahead and go ahead and go through the lesson today. All right? So let's look at your page for today. Have a new concept at the top, mixed numbers. Mixed numbers, okay? So what do we mean by mixed numbers? Well, let's check this out. We have studied, this is a fairly simple concept. We have studied whole numbers. Let's see. Cam. Hey, Cam. Whole number. So let's think about some whole numbers. Hope you're doing well today. A whole number. I'll say 20. Okay? 20 is a good whole number. You think that's a good number? Yep. It can have a whole number can have 1 digit or 2 digits. It can be the number 5. That's fine. We can use it that way. It can be 3 digits. 148. All right, so let's think about good whole numbers. We've talked about fractions, fractional parts. Let's see who I have here. Charlie. Hey, Charlie. Fraction. Fraction has a numerator and what, Charlie? A denominator. That's right. 2 numbers. So let's think of some fractions, okay? You notice that church likes, I always seem to use 3/5, 1/2. Okay, so those are some fractions. Now, let's talk about putting those numbers together today, okay? Mixed numbers. Look at your box at the top of the page. A number that combines a whole number and a fraction is a mixed number. So there's two parts to a mixed number: a whole number and a fraction. You're putting them together, two components there. If you look at your circles there, you have two circles completely filled in, so hence the number 2. And then you have the half. Half of that is shaded, right? 1 out of 2. That's how I get that fraction. So this mixed number is 2 and 1/2. I have two components. I've taken a whole number right here, and I've taken a fraction and I've joined them together. I did not want my whole circle filled in there, shaded in, so it's a fraction. So you're putting those whole numbers, meaning the whole object is shaded in, whether it's a circle, a square, rectangle, whatever it is. And then you have the part of the next shape is your fractional part, okay? Fraction being an equal part of a whole, all right? So let's look at number 1 together. I think this is a pretty easy concept for today. A good way to end our week, something fairly easy. So let's look at number 1A. Number 1A, let's see. Jill. Hey, Jillian. So let's see. You've got your paper there. You're looking at number 1, those purple circles there, 1A. We're looking for a mixed number, Jill. So a mixed number has to have a whole number and a fraction. So let's look at it and see what we have. Jillian, how many circles are completely shaded in? 2. 2 of those are completely shaded in. So we're going to start with the 2. All right, now look at the bottom circle, Jill. You've got the 2 written. Look at the bottom circle. What is my fraction there? How many pieces are shaded? 2 out of how many altogether? 3. So your answer there is 2 and 2/3. And that's how we would read it. 2 and 2/3. 2 and 2/3. Okay? Let's look at B. So we're going to start with our whole number. Whole number being which or how many are completely shaded in. You have squares here. So how many squares? Now they're divided into sections within, but how many of those squares are completely shaded in? 3. That's right. 3 of those are completely shaded in. Now, look at that one that has a fractional part of it shaded in. So let's start with the numerator. How many pieces are shaded in? Just 1. Right? 1 out of how many? All together, included the shaded part. 4. Right. So 3 and 1/4. Okay? Just pretty easy. Everybody okay? All right, let's look at C. Let's look at C. Lillian. Hey, Lil. You probably already have it filled in there, so let's go back and look at it. We have C filled in, C there to figure out. You have C. How many of the shapes are completely shaded in? These are pentagons. How many of those are completely shaded in? 2. Right. The bottom one, the one that's not completely shaded in, Lillian, how many pieces are shaded? 3. That's right. 3 out of how many altogether? 1, 2, 3, and then count the other 2, 4, 5. So your mixed number is 2 and 3/5. Let's look at D. Yikes. That looks different, doesn't it? Look at the top part. You have your rectangle there divided into sections. You have the first section, the first shape. How many sections are shaded? That's a tongue twister. The whole thing. You have 10 blocks there. All 10 of those are shaded. So 10 out of 10, 10 over 10 equals what? 1. Okay, so we have 1. So don't let that fool you there. And then look at the bottom box. How many out of 10 are shaded? Right, you have 7 tenths. So 1 and 7 tenths for D. Okay? Any questions about those? Any comments, concerns, anything like that? Just let me know. Okay? So let's look at number 2. Mark the circle under the mixed numbers. Mixed numbers, a whole number and a fraction. 5 1/2. Yes. Fill in that circle. That's a mixed number. 7? That's just a whole number. It's just 7. 3/4? Nope, just a fraction. 7/8? Nope, just a fraction. 6 1/2? Yes, that's a mixed number. Fill in that circle. 3 1/4? That's 2 parts. Whole number and the fraction. 12/17? Nope, just a fraction. 9? Whole number. 15 2/7. Yes, that's 2 parts there. Okay? So let's look at number 3. Going back up to your box for just a second. The second point there. The number 2 1/2 is greater than 2, but it's less than 3. So if I have 2 cookies and you give me half of yours, then I have 2 1/2 to eat. But if you have 3, then you have more than me because you have a half more than what I have. So let's look. It says fill in the blanks with less than or greater than. So let's compare. 6 is less than 6 1/2. That's right. If you have 6 and I have 6 1/2, I have a half more than you. So you have less than I do. 3 5/6 is greater than 3. That's right. Even though it's a fraction, it's still more. Even though it's a small part, it's still more. So 3 5/6 is greater than 3. Let's look at number 4. 4 2/3 compared to 5. It's still smaller, right? You haven't made it to 5 yet. So 4 2/3 would be smaller than 5. Because 4 is smaller than 5. You haven't gotten all the way to 5. And let's look at D. 9 compared to 8 7/8. Sure, 9's greater. If you have 9 whole pieces and I only have 8 and a fraction of a part of another, I don't have as much as you. It might be just a bite. Maybe that cookie broke, but you have more than I do because you have 9 whole pieces. So 9 would be greater than. Okay, number 4, list the numbers you could use to reduce each fraction and then circle the best choice. Okay? 8/20. You're thinking, okay, I'm thinking number 1, 8's an even number, 20's an even number. So we'll start right out the gate with 2. That's right. 2 would be divisible into both of those numbers. So let me think. 3? No. 8's not divisible by 3. 4? Are both of those numbers on the 4 table? Sure. So you have 8 divided by 4 would equal 2, and 20 divided by 4 would equal 5. So you would have a 2 there in the first blank and a 4. And then we're going to circle the 4 because the 4 is the larger number there. So then you're going to come down to number 5, and you're going to, if you need to make you a little workspace, you can say 8/20 divided by, and then look back up. Which number did we choose? The 4. 4 over 4. 8 divided by 4 equals 2. 20 divided by 4 equals 5. So that would be 2/5 there. Okay? And you can do B and C. D should be super easy. It's not going to be 10. But think, what table would you see both 10 and 25 on? That's an easy table. Okay? So you have number 5 to do. Number 6, story problems. Ava helped pack away Christmas ornaments. There are 72 ornaments. Each box holds 9 ornaments. How many boxes will she need? What are we doing with the ornaments? Are we multiplying them, adding them? You're right. We are dividing them. So we're going to go over to our workspace and divide that. Okay? Letter B. 2-step. Abby, 2-step. You got it. Oliver earns $4.50 per hour helping with yard work. If he works 3 hours every Saturday for 4 Saturdays, how much will he earn? The first step that you have to do there is you have to decide how much is he earning on a Saturday. So for one Saturday, he's working 3 hours and he earns $4.50 per hour. He's working 3 hours. So your first step is you need to take the $4.50. He's getting paid by the hour. How many hours is he working? He's working 3. Okay? And you'll figure up what he's paid for one Saturday. But that's not the question. The question is, how much will he earn every Saturday for 4 Saturdays? So if he works 3 hours every Saturday for 4 Saturdays, how much will he earn? All right? So you're going to take this number. 3 times 0 is 0. 3 times 5 is 15 plus 1. 3 times 4 is 12 plus 1 is $13.50. And let's just pretend like he's going to work a month of Saturdays. He's taken the whole month of April and he's trying to save up some money. How are you going to find out how much money he's going to make in a month? I'm going to let you decide that. Okay? His money, multiplying his money. 4 Saturdays. Okay? Number 7, divide and check. No remainders. Be careful with B. You can short divide there, or you can start with the 0 step. Whichever you want to do is fine. Look at number 8. Solve the measurement equation. Oh, you've got 3 components to this problem. I'm going to get you started. Not going to work the whole problem for you. So I want you to be able to get started here, but then see if you can. 6 gallons plus 3 quarts plus 12 pints equals, get to the end here, blank quarts. Okay? So what are we solving for? We're solving for quarts. So I'm going to bring my quarts under. Process, adding. Process, okay, adding, yep. Now, we have to draw our boxes around the different measurements. Gallons and quarts the same? No. So there's one box. Quarts and quarts the same? Sure. So we're just going to bring down 3. pints and quarts the same? Nope. Draw a box there. Please don't just add those numbers up. You can't add gallons and quarts. That's not the same. So then you're going to come under. You're going to bring down, let's see. I've already brought that down. So let me do 1, 2, and 3 here. Okay, got that. So come in and solve. Put your answer here. Solve. Put in your answer here. And then you'll add them up because we have quarts, 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 and quarts. So we can work with that. All right. Number 9, find the fractional parts. That should be easy for you. Homework. Number 1, you don't have to write the 10 table. You don't have to do that. And for number 2, I'd like for you to do number 2. Let's do the 9 table. So we can practice 2A and 2C. You don't have to do B and D. So 2A and 2C. Okay? So that's the end of our math lesson for today. Any questions, you are welcome to send me a text, or you can rewind the video and see, where you left off, what your questions are. Okay? So that's it for math today. If you're following along with us in our daily schedule, we're going into reading next, and we will need your Maple Tree book today, and then you have a packet kind of stapled together of some reading comprehension to do. Okay? So reading is next.